Good morning, everyone. I wanted to read to you something before we begin the solution to the polynomial problem. I wanted to read to you something that I told you a few weeks ago I was going to share with you all, time permitting, some of the writings that I did as an undergrad, that I wrote as an undergrad. And I found in my papers this morning, just because I was going through my papers for this video to see if I could share something inspirational with you all, something that perhaps some of you, of course, will not agree with me, and that's okay too. But it was really an essay I had to write in one of my. I minored in political science. So those of you who are new to the channel and you don't know me or you haven't seen the other videos, I am a graduate of. I did my undergraduate degree. I got my bachelor's degree in mathematics, but I minored in political science at Columbia University in the city of New York, as they used to say, Broadway and 116th Street. I used to have a little sign that said, when you arrived, turn right." No pun intended. But I enjoyed my time at Columbia. But I found the one of my exam books from my class, and they used to give us. I doubt they still do this now, but I'm covering because I have my social security on here and things like that, and date of birth. But this was this was our test booklets. It was very typical in humanities courses to have this, and you would have to write essays. So I'm going to read to you part of the an essay that I wrote. The essay was on welfare policy. Welfare policy, and I know some of you are going to disagree with me, but I think a lot of you young people who have the right ideas will be perhaps you'll know that you're not alone. That there were many of us before. Those of us who have certain ideas don't feel all alone. College campuses for a very long time, ever since the middle of the 20th century, have always had, particularly Columbia University and similar universities, have always had a hostile environment for those of us who have classical ideas. Ironically, they used to have the classical curriculum, although they phased it out in a lot of places. A lot of places have become a lot weaker now. But anyway, I'm going to share with you, I'm going to read to you what I wrote about welfare policy. I am for the presidential candidate who will balance our budget. Sound familiar to these days? No matter who gets fired, no matter no matter how empty the Pentagon would look, no matter how many friends and buddies and uncles and brother-in-laws get shipped home, balance our budget and the same time increase and at the same time increase our defense budget to whatever level it takes to make us one more time the number one nation in the world. Mr. Teddy Roosevelt had the right creed. He said, "Speak softly and carry a big stick." That's the only language our enemies understand. You ask, how in the world are you going to balance the budget and increase the defense budget? It cannot be done. It can be done very simply. All we need to do is drastically cut, if not totally eliminate, this blooming welfare state program at home and abroad and use those monies to intensify our defense development. I believe in taking care of people who cannot work. I believe in taking care of the elderly. I believe in a social safety net. I believe in assisting people who cannot work. But I do not believe in giving us a red cent to people who can but will not work. There are many people in America who would not work in a pie shop eating the holes out of donuts. And there's more, I go into it a lot more. But that's just so you see that there has always been, for decades now, the problem in this country with people just living off the state, people not willing to work. It's nothing new. I wrote this decades ago. And we're seeing now similar debates, right? There's been a lot of complaints about Doge. They're saying Doge is firing people and all that. A lot of people are crying. Now, I'm not celebrating that people are losing jobs in the federal. But you know what the government, I have always told people, and those of you watching, if you are a government worker, let me tell you something. What the government gives you, it can also taketh away. And if you were naive enough to depend on the government, then you were either ignorant or you really believed that you had some sort of divine right to have a federal job. What the government gives you, it can take away. All money comes to the government from the taxpayer. So if the government is no longer productive in some way, those are fake jobs. And we need to really train ourselves, particularly those of us who are of a certain age, and that applies to me just as much as it applies to you. We really have to, step the game up, step the game up, improve our skills, always learn new skills. Even if you're I'm a mathematician, but even if I'm a mathematician, there's always things that you can do, or there's always new things that you can learn. There's always new things that you can contribute. But anyway, here goes for the polynomial solution that you've all been waiting for. All right, so the original problem that you see on the board here, this was the original problem. It said reduce the given expression to a monomial with a degree of 72. Then, which of the given choices represents the coefficient of the monomial? Now there's a lot to unpack here, because what I was going for with this question, I was trying to test your skills on vocabulary. I want you to know what a monomial is. You should by now, if you're in high school, especially if you're in college and you're taking college algebra, for example, or even calculus, and you don't know what a monomial is, you're in big trouble. You better know what it is. So a monomial, and you can look it up. I don't have time to do it on this video, but if you don't, you can look it up easily. Monomial. But basically, we're looking for one term, a single term, with a polynomial of a single term with a degree of 72. You should also be familiar for this problem with what the degree of a term is. So the question says that which of the given choices represents the coefficient specifically of the monomial that you get? Well, a couple of things here. Anytime you see a problem like this, always look to see if there are patterns that you can take advantage of. So, for example, inside the brackets, I already notice that that the bases are the same in the numerator, and they are also the same in the denominator, right? Even though they are written as radical expressions, we know that the radical is the inverse of taking of squaring or cubing or raising a term to a particular exponent. So, and then outside the brackets, we have a fraction, m of x equals x to the n divided by 4,096. And there is a 4 outside that parentheses. Well, a couple things. When you're dealing with big numbers like the 4,096, and you know that the question is asking you about some kind of exponential or some kind of radical, always think to see if you can simplify or write it exponentially, that 4,096, for example, because I don't want to deal with 4,096, and I'm sure you don't either. You can always rewrite things to simplify. So the denominator there, the 4,096, you should know that you can actually, if you use the base of 2 and you raise 2 to the 12th exponent, you get the same thing as 4,096, right? So also take into account, you should be familiar with the rules of exponents. That's one of my obsessions with algebra students. They don't know the rules of exponents successfully enough. You have a vague notion, most of you, but you don't really apply it to the logical conclusions. So notice that outside, don't worry about the brackets just yet in this step. Notice that you have outside the parentheses, you have an exponent of 4. Remember that by the laws of exponents, that 4 has to go to distributes to the n here, and it's also going to apply to this 12 here. So have that in the back of your minds as we progress on this problem. Now, inside the brackets, right, these are what we call, you notice that there's a lot of radical symbols in here. These are what the expression that we use for that, we call those nested radicals. right? You notice that there's a radical within a radical within a radical, etc. The number that is outside a radical sign, by the way, those n's, that's called the index, right? You should know what an index is because I went over it in one of my previous videos when I was discussing squaring numbers and the laws of rational exponents. So one way to simplify this, you notice that there are 1, 2, 3, 4. There are 4 radical signs in the numerator. There are also 4 radical signs in the denominator of this big looking fraction. So if you want to break it apart as an index, that means n times n times n times n. We're going to do that on the top and we're going to do that on the bottom. Now, the tricky part about this, it's not hard, but you just have to be very careful with your signs and with your eyes. You notice that the base, they're all the same base, right? 2x, and then there's an n, then there's 2x. Now be careful. All exponents, when you don't see it written out, like in this case, you just see 2x, there's really a 1 there. 2x to the 1 times n. 2x to the 1 times n, etc. So I hope you all remember from the laws of exponents, when you have the same base, you add the exponents, right? So to give you a numerical example, and before going back to this, if you had, let's say, the same base, 3 squared times 3 to the third. Well, the bases here, the big numbers, the 3 are the same. This means 3 to the 2 plus 3. And this means that you can write that as 3 to the fifth, right? Likewise, if you have a variable, let's say you have x to the m times x to the c, the bases again are the same. So this means x to the m plus c. Bear that in mind. All right, now let's go back to the problem. You notice that since all of these x's have a 1 as the exponent, then you can write it as it's going to be times plus, times plus, times plus, etc. Right? Because the first 2x here, it's 2x to the 1. That's 1 times n. So you can see I wrote that in the, it's rather small, I know, but it's really 1 times n. I do apologize if you can't see it. I'm going to try and make it neater in the next part. But 1 times n, and then you add, notice that there's a plus 1 because the next 2x is 2x to the 1. So it's 1 times n plus 1, and that is going to be multiplied to n plus 1, and that multiplies to n plus 1. And it makes sense, right? Because you started, there are 3 more 2x's here. So your exponent looks like this so far before we simplify. All of that, don't forget, all of those brackets are being raised to the n to the fourth. Now, in the denominator, you still have the same index, right? N, but your base is the same too. That's great. But instead, when you are dividing exponents, you know very well that you have to subtract the exponents if the bases are the same. And so as a numerical example, if you had, let's say, 3 to the 8th, right, divided by 3 to the 5th, this is really 3 to the 8 minus 5, which gives you 3 to the third, right? And likewise with variables, a to the b divided by a to the c equals a to the b minus c, right? That's the logic behind it. That's the theorem behind it. So in the denominator, we're not going to, of course, add, we're going to subtract. So again, the 2x has a 1. So we have 2x to the 1 times n, but then we have to subtract the next one, right? The denominator, minus 1, right? Then we multiply that by n plus 1. Be very careful with your signs. Notice what happened here. The sign changed because minus minus goes to a plus now. Then you have that times n minus 1. What I'd like you to do is to simplify. I'm going to write the 2x, the exponents on both, and I want you to simplify them. So, sorry here. So the numerator is going to be 2x. Maybe here you could see it better. 1 times n plus 1. That's going to be multiplied. Again, the pattern follows. N plus 1. And that multiplies to n plus 1. Right? So what I'd like you to do is simplify that before I show you the next part. You can pause the video. And then in the denominator, we have 2x, and then the x is being raised to 1 times n minus 1, and that's going to be multiplied by n plus 1, but then it goes to n minus 1 because you have to be careful with the signs. All right, so what I like you to do is simplify the numerator exponent and the denominator exponent, and then I'm going to show you what it is simplified, and you let me know if you got the same thing. All right, so this is what what you should have operated. The numerator that the exponent for your numerator that you should have simplified to should have been what you see circled here. N to the third plus n squared plus n plus 1. Notice why. When you multiply 1 times n plus 1, multiply that by n plus 1, and then all of that times n plus 1, if you use the laws of distribution, well, n times 1 is n, right? So n plus 1 times n gives you n squared plus n, and then you have that plus 1. All of that times n plus 1. Well, the n distributes to every element inside the parentheses. So n squared times n is n to the third, n times n is n squared, and n times 1 is just plus n. So now you have n to the third plus n squared plus n plus 1. Now for the denominator. What you do, same operation, except the signs will be changed. And you should have gotten n to the third minus n squared plus n minus 1 as your exponent for the denominator base. And why is that? Because you have 1 times n minus 1, all of that times n. The n distributes, so you get n squared minus n plus 1, right? And then you have n negative 1 that you have to bring down. So all of that gives you this denominator here. All right? So now we have to incorporate that as part of our problem. We have to incorporate that as the exponents in the numerator and the denominator. All right, so this is what when you incorporate it into your expression, this is what it looks like. Now notice that we said that 4096 is really 2 to the 12. But because you have an exponent outside the parentheses, you have to distribute it by the laws of exponents. So the numerator becomes x to the 4n, and the denominator becomes 2 to the 48, right? Because 2 to the 12th, right? But it was 12 times 4 now, so it becomes 48. Then inside the brackets, remember that our index was written, I broke it down. I'm trying to solve it step by step so that you see every procedure, but you could have done, those of you who are more comfortable manipulating things, the n times n times n times n really is written as n to the fourth, because that's n to the 1 times n to the 1 times n to the 1 times n to the 1, all the same bases. You add all the exponents. Math is beautiful. And so in the index, in the numerator and the denominator is now n to the fourth in both cases. And then what I did was we incorporate the exponents that we got for the numerator and the denominator. So we have 2x raised to the n cubed plus n squared plus n plus 1. And in the denominator, we have 2x raised to the n cubed minus n squared plus n minus 1. Brackets, you notice you have a 4 as an exponent outside the bracket, which means that the 4 has to be distributed to both the numerator and the denominator. So let's see how we can incorporate that. I would like you to simplify it and see what you come up with. Pause the video, please. Now notice what happened here, right? So your simplification should be, we said that the index was n to the fourth, and outside the brackets we had, I wrote it in the just a little bit before as to the fourth, but it's really n to the fourth. I'm sorry about that. This is the original, right? So it's being raised to n to the fourth, not just 4. So now you notice that, what do you notice in common? And if you know your roots, you know very well that they actually cancel out beautifully. The n to the fourth here, n to the fourth here, n to the fourth here, n to the fourth here. So now really you're left with your expression that you are left with is x to the 4n divided by 2 to the 48th, and then this, right? This is what we're going to have to operate next. So see what you can do so far, and then we'll talk about it. All right, so here is our continuation of the problem. When you simplify everything, notice that now you have x to the 4n divided by 2 to the 48th times 2x divided by 2x, and then those exponents. Now, we said earlier, and you should know this, when you are dividing by the same base in an exponential expression, you can subtract the exponents. So if you notice here that you have 2x, you have the same base, so you can subtract the n cubed minus n squared plus n minus 1 from the numerator exponent. And that leaves you with 2n squared plus 2, right? So now your expression looks like as follows. M of x equals x to the 4n divided by 2 to the 48th multiplied by 2x raised to the 2n squared plus 2. I want you to operate that. Be very careful here. I want you to operate that. I'm testing something very specific here, and then we'll see if you got it right. All right, we are almost done with this beautiful problem from City Tutoring. We have, what I was testing is, a lot of students make this mistake. Let's go back a little bit up here. What they do is, I'm going to underline it in red. They take this whole thing and say, oh, 2x to the 2n squared plus 2. No way! Be careful. The exponent distributes both to the 2 and to the x. And therefore, when you break it down, you have what you see here. X to the 4n divided by 2 to the 48th times 2 raised to the 2n squared plus 2 times your x to the 2n squared plus 2. And now you are also going to break it down. There's a division in here. Notice what happens. You have the same basis. The x's can be combined in terms of the exponents. So you have 4n plus 2n squared plus 2. Writing it in descending powers, you have 2n squared plus 4n plus 2, right? All of that, and now you have 2n squared, right? The coefficient here is going to be 2n squared minus 46, the 2, because the 2, you notice that there's a 2 in the numerator and there's a 2 in the denominator. So that means 2n squared plus 2, you subtract exponents, the exponent of 48 subtracted from the plus 2, so you get 2n squared minus 46. So it's 2 to the 2n squared minus 46. That's why I put the coefficient there, by the way. The coefficient is the number that is attached to a variable in a monomial. All right, so the definitions are very important. So now we're almost done because the problem is asking us, let's go back to the problem. Reduce it to a monomial. We need to have a degree of 72. Then which of the following represents? Okay, so the degree of a monomial, I want you to try it first and let me know what you come up with and see if you get it right. And we now arrive to our answer because now you have, we talked about the degree of a monomial, right? We should have been studying that for a while. The degree of a monomial means the sum of the exponents of all its variables. So notice that the variable part here is 2n squared plus 4n plus 2. And all of that is going to equal, according to our problem, 72. So we set it equal to 72. Now you can always simplify, or usually if you can do so, in this case you can reduce this by dividing by 2. And that gives you n squared plus 2n plus 1. 72 divided by 2 is 36. That makes your life a lot easier when you're dealing with smaller numbers. And now you have n squared plus 2n minus 35 equals 0. We move because we moved the 36 to the left side to get a quadratic that is easily solvable. And now we can factor this. n plus 7, n minus 5. We use the zero property, set them both equal to 0, and our solution set is either -7 or 5. However, remember from the original problem, the n was representing an exponent of the monomial, right? So you cannot have, by the way, negative exponents in a monomial. It is not permissible in mathematics. And therefore, you can only use the solution of 5 here, n equals 5. So now all you have to do from there is plug it into we're asking about the coefficient specifically. So the coefficient was 2 raised to the 2n squared minus 46. That gives you n squared. N is 5. That's 25. 25 times 2 is 50. 50 minus 46 gives you 4. 2 to the 4th. Finally, you get an answer of 16. So good job, those of you who got 16. If you did not get 16, that is probably because you've either not been exposed to monomials and polynomial definitions, or because you might have messed up the exponents at some point. So I hope this is helpful to you all, because you can see how beautiful math is, and it follows all the logical truths and all the properties that you are taught about polynomials. You can always rely on them to come up with a lot of interesting problems. So thank you all. I will see you on Sunday. On Sunday, we're going to talk about a Sunday message. We're going to talk about the types of men you should be around. Because a lot of people have asked me to do a follow-up video on that other video on where I mentioned types of men that you should not be around, right? So we're going to talk about the good types of men that you should be around, good types of people in general. But anyway, thank you all. Enjoy, and may you have a blessed day.